This is the video for section 7.3 notes, slides 23 through 25. All right, so problem number 6 says the integral from 0 to 4 of negative x over the square root of x squared plus 9 dx. All right, so first thing we're going to have to do is we're going to have to try to figure out how to integrate this thing. All right, now, in order to integrate this, we're going to have to use a u substitution. So we're going to have to let u equal x squared plus 9. All right. So x squared plus 9. All right, and so if we do that, that means that du is equal to 2x dx. All right, so now that means I'm going to have the integral, and I have u to the negative 1/2, and now I have the negative x dx. So I'm going to put the negative 1 on the outside, all right, and then I have the x dx. All right, now it's also important to note that the integral is from 0 to 4. So remember, that is an x value. So x equals 0 and x equals 4. It's important that we put x equals to make sure we keep in mind that those are x values and not u values. All right, so du is 2x dx, and so that means I need a 2 with the x dx, and that means I need to divide it by 2 on the outside. So I have negative 1/2 the integral from x equals 0 to x equals 4. So it's important that I keep those as x equals, just to make sure that I'm keeping track of what value those numbers are. And then I have u to the negative 1/2 du. All right, so now there are two ways that I can go about doing this. All right, I can integrate and keep these as x equals, or I can change these to u equals values. All right, so I'm going to show you both. All right, so the first way that I'm going to do it is I'm going to change x equals 0 and x equals 4 to u values. All right, so let's go over here. If u is x squared plus 9, what is u when x equals 0? All right, so what is u when x equals 0? So make sure that we think about that. Well, if x is 0, then this is 0 squared plus 9. And so that means u is 9. So that means our lower limit is going to be 9. All right, what about the upper limit? What is u when x equals 4? So 4 squared plus 9. So 16 plus 9 is 25. So that means the upper limit becomes 25. Now, I'm not writing x equals anymore because these are no longer x values, okay? They are u values, okay? And so I don't have to write u equals anymore. I could, but I don't have to because now u is the only variable in my problem, right? Up here, when I had like u to the negative 1/2 times 2x dx, well, I have to make sure I recognize what those numbers go with. All right, so now let's integrate. So I've got the negative 1/2 on the outside, and I've got u to the negative 1/2. So I add 1 to the power u to the positive 1/2 and then divided by 1/2, right? And then now remember, with a definite integral, we don't have to add a c. We are simply going to evaluate this from 9 to 25. All right, so now I can simplify a little bit. The 1/2s would reduce, and so I'm just left with negative, and then I have u, so 25 to the 1/2 power minus negative 9 to the 1/2 power. Remember, you put the upper limit in first and then subtract with the lower limit. All right, so what does the 1/2 power mean? Remember, it means square root. So square root of 25. So I have negative 5 plus, right, minus a negative. Square root of 9 is 3. And so my answer is negative 2. All right, but let's make sure we understand it from the other perspective. The other perspective is to keep the x equals there. So negative 1/2. All right, so now the integral of u to the 1/2 du. So now I'm going to integrate and I'm going to get u to the positive 1/2 over 1/2 just like before. But now I'm evaluating from x equals 0 to x equals 4. All right, now I keep those as x equals to remind me that instead of u here, I can't just plug in 0 and 4 for u. I actually have to take x squared plus 9 and plug that back in for u. And so once again, the 1/2s reduce. And so I'm left with negative, and then I have x squared plus 9 to the 1/2 power. And then from 0 to 4. Now notice how I drop the x equals because now x is the variable in the problem. All right, and so then I'm going to plug that in. So I get 4 squared plus 9 to the 1/2 minus negative 0 squared plus 9 to the 1/2. Sorry, I kind of ran out of room here. Plus 9 to the 1/2. All right, and so 4 squared plus 9, so 16 plus 9 is 25. So I get negative 25 to the 1/2, and then plus 0 squared plus 9, well, that would be 9 to the 1/2. Well, you can see this is the same thing that we got earlier, right? Negative 5 plus 3, of course, gives me the negative 2, right? So it's just two different methods of getting the same thing. All right, so that is slide 23. All right, so let's take a look at slide 24, a little bit easier now. All right, so I've got the integral from 0 to 5 of e to the negative 3x. All right, so I'm going to do a u substitution of negative 3x. So I have the integral from x equals 0 to x equals 5 of e to the u dx. So remember, du is negative 3 dx. So I need a negative 3 with the dx and a negative 1/3 on the outside. So now I have negative 1/3 integral of e to the u du. Now I'm going to change these limits from x equals to u's. So if u is negative 3x, what is u when x equals 0? Well, that would be negative 3 times 0, of course, so u would be 0. So the lower limit is 0. What is u when x equals 5? Well, negative 3 times 5. And so negative 15. So the upper limit becomes negative 15. All right, so now I have negative 1/3. Integral of e to the u is just e to the u, and then I'm going to evaluate from 0 to 15, right? Sorry, 0 to negative 15. All right, so now don't worry that it's negative, right? That they don't go in order. You have to put them in the appropriate place. So now I have negative 1/3 e to the negative 15 minus negative 1/3 e to the 0. All right, and so that would get me negative 1/3 e to the negative 15th. Remember, that means 1 over 15. So this would be like negative 1 over 3 e to the 15th plus 1/3, right? So you could have that, or you could like combine them by getting a common denominator or something. So you would multiply by e to the 15th over e to the 15th, right? And so I could have like negative 1 plus e to the 15th over 3e to the 15th. But each of them are, basically correct. We just have to remember that if we're looking on like the answer sheet or, multiple choice or something, one of them might be different. All right, what about the next one? All right, so first thing that I want to do is I want to realize that this is really like 3 times the integral of 1 over x dx. And then I have from 2 to 4. So no u substitution is required here. So I have 3 times, what is the integral of 1 over x? That's natural log of the absolute value of x. And then I'm going to evaluate that from 2 to 4. All right. And so now I'm just going to plug in. So 3 natural log of the absolute value of 4 minus 3 natural log of the absolute value of 2. Now, 2 and 4 are positive numbers, so the absolute values are not necessary. All right, and I can factor out a 3, so I get 3 times the natural log of 4 minus the natural log of 2. Now, natural log of 4 minus natural log of 2, that can be rewritten as the natural log of 4 over 2, and 4 over 2 is 2, so this would be 3 natural log of 2. Right now, that is very likely the answer, but sometimes it's possible that it could be rewritten. We could bring that 3 in as a power, and this could be the natural log of 2 cubed or the natural log of 8. So remember, we just have to make sure that we can recognize different versions of the same answer. All right, so that is slide 24. All right, and let's finish off with slide 25. All right, so number 9. Okay, I've got the integral from 1 to 3 of x to the 2x squared. So we're going to have to do a u substitution. So u equals x squared. So du equals 2x dx. So I'm going to have the integral of from x equals 1 to x equals 3 of 2 to the u, and then I have the x dx. So now remember, I needed a 2 with the x dx, so I need a divided by 2 on the outside. So I have 1/2 integral of 2 to the u du. All right, now what about the limits if x equals 1? So what is u when x equals 1? So that would be 1 squared or 1. So the lower limit is u equals 1. What is u when x equals 3? So that would be 3 squared. So that means the upper limit is 9. So I have 1/2 integral from 1 to 9 of 2 to the u du. All right, so now we're going to integrate 2 to the u. So remember, the integral of 2 to the u is 2 to the u divided by the natural log of 2, and then evaluate that from 1 to 9. And so I get 1/2 2 to the ninth over the natural log of 2 minus 1/2 2 to the first over the natural log of 2. Now, 2 to the first and 2, those reduce there. 2 to the ninth and 2, those reduce, giving me 2 to the eighth. So I have 2 to the eighth over the natural log of 2 minus 1 over the natural log of 2. Obviously, these have a common denominator. So 2 to the eighth minus 1 over the natural log of 2. But 2 to the eighth, what is 2 to the eighth? Well, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, and 2 to the eighth is 256. So 256 minus 1, so this would be 255 over the natural log of 2. All right. And so you do need to be able to do that without a calculator. This is important because in a multiple choice setting, you would need to simplify. In a free response setting, you could stop right here. You would not have to go any further than that um, because it's a numeric answer. And so we'll talk more about that in the future. All right, so number 10, we are going to need a u substitution. So u equals x divided by 2, and so du is 1/2 dx. All right, so I have the integral from x equals 0 to x equals pi over 3, and the tangent of u, and then dx. So I'm going to need a 1/2 with the dx, which means I need a 2 on the outside. So 2 times the integral of the tangent of u du. All right. Then we need to figure out what the limits are. So what is u when x equals 0? So that'd be 0 divided by 2, so u would still be 0. And what is u when x equals pi over 3? So we have pi over 3 over 2. So pi over 3 divided by 2, remember, that becomes pi over 3 times 1/2. And so that would be pi over 6. All right, and so now I'm going to integrate tangent of u from 0 to pi over 6. So I have 2 times integral of tangent. Remember, this is the natural log of the absolute value of secant of u. And then we're going to evaluate that from 0 to pi over 6. So 2 times the natural log of the absolute value of the secant of pi over 6 minus 2 times the natural log of the absolute value of the secant of 0. All right, so now what? All right, well, now we need to simplify with some unit circle. So the secant of pi over 6, remember the secant is the reciprocal of cosine, right? So cosine of pi over 6 is root 3 over 2. So this would be 2 over root 3 minus 2 times the natural log of the secant of 0. The secant of 0 is 1, right? Because it's the reciprocal of cosine. Now, the natural log of 1 is 0. So this second term becomes 0. So we just get the natural 2 times the natural log of the absolute value of 2 over root 3. But remember, absolute value is not necessary because 2 over root 3 is positive. All right, so now you might have this, or remember, you could bring this in as a power. And so that would square this. So it would be the natural log of 2 over root 3 squared, which would be 4/3. And so that would be kind of the simplest version of that answer. All right, so that is slide 25.